Hello, this is my presentation on time dilation. Sorry for it not being in the presentation format. It wouldn't work and I don't know why, so I kind of gave up on that and I'm going to do it in this format so you can see the slides on the side, so sorry about that. What is time dilation? Time dilation is basically the process in which there is a difference in time measured between two separate reference frames, one of which will be the reference frame we know on Earth, and the other, in most examples, is an object moving extremely fast in space, because that's where the difference is most profound. And going off of that, the difference in reference frames is largely determined by the speed of an object. The faster it's going, the more profound the difference in time is going to be, which is the basis is like how close it is to C. If it's much closer, there's going to be a lot larger of a difference. And you can see the formula for time dilation on the side. You can see that on the left we have the dilated time, so the time that will be seen in the moving reference frame is equal to the time in the stationary reference frame, or the one that you were observing, divided by the square root of 1 minus the velocity an object is moving at divided by c squared. So basically the ratio of how much of c the object is moving at, like I was saying. And to add, this isn't just an illusion. It's a real thing. And time would genuinely pass at different speeds if we were able to ever create objects that could go this fast. An example being the twin paradox, where if two identical twins were to, or if one of them were to leave Earth and go on a spaceship at an extremely high speed close to C, then if they returned relative to the first twin, they would be much younger, as time had dilated and gone much slower for them. So if the time as an object increases in speed as the velocity of an object approaches the speed of light, we know that the time would decrease or would slow down. So what would happen to its length, the length of the object? You can answer that now. The answer is that it would shrink. I'm sure you got that. And that refers to length contraction. Length contraction is another side effect of very, very high speeds in like in space, probably in space. And it refers to an object as the velocity of an object increases, it shrinks. Its length, it shrinks in length proportionally. And we see the formula on the right. The length of an object you observe is equal to the length it actually is, multiplied by 1 minus the ratio of the velocity squared and the speed of light squared. So it's very similar to the time dilation formula, as it's part of the same phenomena, but it is different in that it's referring to length and not time. So applying this to an example problem, we have a problem. The brightest star visible from the northern hemisphere is the star Sirius, which is 8 light years from Earth and in the constellation of Canis Major. It takes a spaceship 4.9 years to travel from Earth to Sirius, according to the spaceship's onboard clocks. According to Earth clocks, the trip takes 10 years. At what fraction of the speed of light did the spacecraft travel? And so a question that I have before we start is, which of the two times would be the dilated time? Would it be the 4.9 years or the 10 years? So you can answer that now. And then actually getting into it, to solve this, you would find the distance traveled in meters, which is just, since there's 8.7 light years, you'd multiply 8.7 by the number of meters in a light year to get 8.2 times 10 to the 16th meters. And then you would have to also convert 4.9 years to seconds, as we're working with dilated time. So 4.9 times the number of seconds in a year, 3.16 times 10 to the 7th equals, is that 15 trillion? I don't know. That's a big number. And then you would divide that number by c, which is, yeah, trillion, 299 trillion. And then after dividing these two, you would get the ratio between the two, which is what the problem is asking for, since it's asking for what fraction of the speed of light, and we would find that it would be just over 1/2 of c, or 0.52 c. So I hope this was helpful.